So for this week's video, what we have planned is basic chemistry of life. So there's actually one part of biology that is uh, called biochemistry. So that's biology and chemistry together. And it's basically talking about the chemical formulas and the chemistry behind some organic compounds like oxygen, hydrogen, carbon dioxide, methane, those kind of things. And then lipids, carbohydrates, those kind of things. So I thought, why not have a video on some basic chemistry? Not specifically of biology, but just in general, like atoms and elements and things like that. BioBliss. So today's topic is the basic chemistry of life. Matter and energy. So matter is anything that takes up space. It can be a solid, liquid, or gas form. The amount of matter in a substance is called its mass. And then the pull of gravity on the mass of a substance is called its weight. So you know how sometimes you want to measure how many pounds you are or how many kilograms you are? Well, you would use the weight scale, right? So that measures how much weight you have, and which is the pull of gravity on the mass of a substance. So the mass of our bodies, that's the weight. So if we have more mass, that means we have more weight. And then we have energy, and that's the ability to do work. It can be transferred to different forms of energy, and it also has the capacity, so the maximum amount, to move matter as well. Next, we have atoms, elements, molecules, and compounds, and those vocabulary words. So all matter is made of atoms, which are particles invisible to the naked eye and to microscopes as well. There are currently more than 110 kinds of atoms that combine in different ways to form many different substances. So a substance made from the same type of atom is called an element. So we have oxygen, iron, boron, calcium, fluorine, neon, hydrogen, many examples. And together all those elements make this table called the periodic table of elements, which we'll talk about later. So when two or more atoms are joined together, they make a molecule. They can be same atoms, different atoms, just any atoms just joined together make a molecule. And here we have a picture. So a molecule, we have oxygen atoms. So these are just two oxygen atoms combined, and that's what a molecule is. Then we have a compound. So when two or more different kinds of atoms, when we know that different kinds of atoms are elements, when two or more different elements are chemically bonded in a fixed ratio, that's when it's a compound. So this has to be only different kinds of atoms. And here of the compound example we have is H2O, which is water. So we have one oxygen atom and then two hydrogen atoms. This ratio will always be the same 1-to-2 ratio for H2O. And all compounds are molecules, but not all molecules are compounds. All right, next we have the general structure of atoms. So atoms are the building blocks of elements and compounds. And although they're invisible, atoms are made up of even smaller particles. So the subatomic particles is what we call them, and there's a picture on the right. So when a proton is one of them, and that is a subatomic particle with a positive charge. We have a neutron, which is a subatomic particle with a no charge. So this is neutral, no charge. And then we have an electron, which has a negative charge. So then here we have a diagram of all the different parts. So we have proton, which is plus, positive, neutron, which has nothing because it has no charge, and then electron is negative. And then it also says the center part of the atom is called the nucleus. So this proton and neutron together is the nucleus. This little bundle of protons and neutrons make up the nucleus. And the nucleus consists of protons and neutrons. These two subatomic particles make up almost all of the mass of the atom. So it's basically all of the mass of the atom contains. While the electrons, which is the negative charge subatomic particle, orbits outside the nucleus. So this region where outside the nucleus is mainly made of empty space. And this is what we call the electron cloud. So all of the space, empty space here, it's actually empty space. This model doesn't really show it, but in reality, it is basically all empty space. And we call that the electron cloud. So while the electrons orbit outside the nucleus, this subatomic particle has such a lightweight mass that when it's rounded, its weight is zero. That's why we usually say protons and neutrons make up the atom's most of its mass, and electrons are a very small amount. Elements, atomic number and atomic mass. So here is one of the element examples. This is carbon, and this is found in almost all living things. This is found in all living things, carbon. And this is the example element I'll be using for this slide, I guess. So we have atomic number and atomic mass. So first up, we have atomic number. The atomic number is the number of protons in the nucleus, which is the same as the number of electrons in the atom. So I haven't said this before, but the number of protons we have the same exact number of electrons. And you may be asking, why is that? Well, think about it. Protons have a positive charge while electrons have a negative charge. So positive and negative cancel each other out. So that's why they have the same exact number of protons and neutrons in the atom. So the atomic number is the number of protons there is, and in this case it's 6. So carbon has 6 protons. That means you already know it has 6 electrons as well. Then we have the symbol. This is the chemical symbol, so it's kind of this letter. We have C, because since there's so many elements, instead of writing each of them out, just write the first or second letter of it. So this internationally used symbols are abbreviations for the common name or the Latin name of the element. So carbon, C. And then we have the name, which is carbon. We already know that. And then we have the atomic mass. So the atomic mass is the mass of an atom of that element. So how do we find the atomic mass, you may be wondering? Well, the atomic mass is, like I said before, it's basically protons, the number of protons you have, plus the number of neutrons you have. And in this case, if you know that there's 6 protons, then you can figure out the number of neutrons by doing the atomic mass by the atomic number. So 12 minus 6. So with that being said, it's not actually 12.0. This actually is 12.001. And the reason that 001 comes in is because the electron has such a very small mass that sometimes we just round it. All right, so here are 12 important elements in biology, because we are talking about biology here, so let's relate it back to that. So first we have hydrogen. Hydrogen is an element that helps keep us hydrated. So we know H2O, water. And then we have sodium. So sodium helps maintain nerve and muscle function. And its symbol is Na, it's the 11th element. And then we have potassium. Potassium helps regulate fluid balance and muscle contractions. You know, when I think of potassium, I always think of bananas, because bananas have a lot of potassium, and it's a very good nutrient to your body, for your body. Then we have magnesium. So this plays the same role as sodium, and it helps maintain nerve and muscle function as well. And then calcium are when shells and skeletons are all made of calcium. So it's that hard thing in our bones that help us stay strong. And then we have iron. Iron is the only metal element we as organisms really need than other metals. So it's crucial to transporting oxygen and producing energy. And notice how iron is not I, it's Fe, and that it gets that from its Latin name. So then we have carbon. Carbon are all, like I said before, all living things are made of carbon or have carbon in them. And then nitrogen. Nitrogen is another essential nutrient that makes proteins. And then oxygen, many organisms breathe in oxygen. And then we have phosphorus. Phosphorus is also another essential nutrient like nitrogen. And sulfur is also used to make proteins. And then we have chlorine, which kills bacteria. So here are just 12 important elements in biology. All right, now for just a very little quiz. So question 1, what is the subatomic particle that has a positive charge called? The answer is C, proton. So an electron has a negative charge, a neutron has no charge, and a proton has a positive charge, and D doesn't make sense. Number 2, what is matter? So matter is anything that takes up space. Number 3, when two or more different, keyword different, kind of atoms, which are elements basically, are chemically bonded in a fixed ratio, it is called a. So two or more different kinds of atoms. The answer is B, a compound. So we know an element is one that's the same kind of atom. A molecule is when two atoms are just joined together. It can be the same, it can be different, doesn't really matter. Compound, it's when it's different and it's chemically bonded in a fixed ratio. And then D is called an isotope, and we haven't really talked about this, but basically what an isotope is when you have the same, you have the, your number of protons, and then the number of neutrons are different from what the chemical element's atomic mass is. And usually some isotopes are unstable and radioactive because they're different from what the actual atomic mass for the element was before. So we'll talk about that later if you don't know what that is. Number 4, what does the nucleus consist of? The answer is protons and neutrons. The nucleus consists of protons and neutrons, like we talked before, and the electrons surround it in the electron cloud. All right, so here we have this diagram A, B, C, D, E, F, and let's just label this parts. So A, we haven't really talked about it, but basically what it is, it's called an electron shell. So an electron shell is, so many atoms don't just have one shell. It can actually have multiple. It can have 2, it can have 3. So we just give the name electron shell because there's different energy levels that it has depending on the amount of protons it has, the amount of neutrons and electrons it has. So it differs by that. So then B, we talked about this. The answer is nucleus. It consists of protons and neutrons, like mentioned before. And then C, the answer is electron. So this is an electron. It surrounds the nucleus, which consists of protons and neutrons. So then E is, D is proton. So proton are the positively charged subatomic particle. And then E is neutrons. This has no charge. And then finally, F is the electron cloud. So thank you for watching this video. Please subscribe and give this video a big thumbs up. And I'll see you guys next week. Bye!